Okay, well, students, last time we have started with the chapter physical measurements and we are taking the topic dimensional analysis. We have covered the definition of dimensions. We have done some of the dimensional formulas as well. For example, distance, displacement, velocity, acceleration, force, work, power, energy, frequency, Planck's constant, universal gravitational constant. Then we have done the physical meaning of principle of homogeneity. Then we have done the uses of dimensional analysis. That is, we can check the correctness of a formula, we can derive a formula, we can convert one system of unit into the other system of unit. For that, we have done the two types of numericals on the basis of the correctness. The first one is, you just have to check whether the given formula is correct or not, like this. If each part or each term of the formula contains same dimension of formula, that means the formula is correct, otherwise it is incorrect. And the type 2, which is very important over here, you can say out of 190% numericals will come on this topic, that is on type 2, if it comes on the correctness. A formula will be given to you, it will be given that the formula is correct, which means indirectly that each of the term of the given formula contains the same dimensions, and by comparing those with the left hand side with the right hand side, we can find the dimensions of the required constants. Just like I take up A, B, C, D over here. We have done these numericals. And at the last, I have told you that with this numerical only, we have already crossed your textbook level and entered into the competition level. Clear? Now along with this, one more type is there. You may have the formula that force is given by ax cube by t square into b plus, this is say a square over here, and b cube. This is equivalent to say ax square upon b cube t plus a upon x square ct square. We have to find the dimensions of a, b and c in this question. What we are going to do is, again we are going to put up the first dimension of each of the physical quantity. Force is mlt minus 2 is a square l cube b cube t square plus al2 b cube t plus ac t square by l square. According to the principle of homogeneity, if this formula is correct, that means each of the term must contain the same dimensions. Normally in the previous numericals, what we have done is, we compare each of the term along right hand side with the term along left hand side. But if I say that the first term is equal to the right hand side term, second term is right hand side term, and third term is also equal to the right hand side term, that also means that these terms are also equal to each other. So in this way, we can solve this numerical in two ways. Either we can compare this first term, say if I take the, for example, first term, comparing it with the right hand side term, I will take out the dimensions of A in terms of B. Clear? Then I will put up the result into the term comparing second with the right hand side. But I have one more convenient way to solve this question. If I compare these two first, that means the first term and the second term along the right hand side, it will give me a square l cube upon b cube t square is equal to al2 upon b cube t. Now if I compare these two, you can see that b cube will get cancelled out. One a will also get cancelled out. You are left with only a over here. L square with L cube and T square with T over here. So you're left with only A L is equal to this T square. When one T gets cancelled out, this T will come over here. Or you can first, in the first step, write down this is equal to 1. Or A will be equal to TL minus 1. Because there is no m, so m will be 0. So we got the dimensions of A. Similarly, if I compare this A of first term with the term along right hand side by putting the dimensions of A, I can get the dimensions of B. So I am comparing the first term with the left hand side term. MLT minus 2 is A square, means TL minus 1 square L cube by B cube T square. I am taking this B cube over here. B cube is T square L minus 2 L3 upon T2, taking this term over here, MLT minus 2. On solving this, I will get m is only 1 over here, m minus 1, L cube L square, L1 will left, and that L will get cancel out with this L. तो ये तीनों आपस में cancel हो गए. This L will cancel out this L. It will come 2. This L minus 2 and this L plus 2 will get cancel out. This T2 will get cancelled out with this T2, and this T2 will come in the numerator like this. This is the value of B cube. So multiplying the powers of each of the term with reciprocal of the power over here, that means by 1 by 3, this B will become, multiplying both sides with 1 by 3, taking cube root on both sides, m1 by 3, T will be 2 by 3, and because there is no L, so L will be 0. So we have got the dimensions of B also. Now if I directly compare this one over here, I can easily get the dimensions of C over here, but I can also compare this A with this B also. We can compare these two terms also. A will get cancelled out, B we know these dimensions, and we can get the dimensions of C. But looking on to the dimensions of B, it's easier in this case to compare this last term with the left hand side term. So I will write MLT minus 2 is ACT2 by L2. What I am going to do is C की डायमेंशन निकालनी है ना, इसको यहाँ पे रहने देते हैं, बाकी सब उठा के उधर ले जाते हैं और A की डायमेंशंस पुट अप कर देते हैं. सो आई विल गेट C is equal to MLT minus 2. This L2 will come over here, T2 आ जाएगा जी नीचे, and this A will also come over here, and the dimensions for A are TL minus 1. Is that okay? Now we are left with M, L1, L2, L3 हो गया, and this will make L4. This minus 1 will become plus 1 while moving to the numerator. T minus 2, and this is T3. This will become T minus 5. So we have got the dimensions of C also. I'm moving on to the next one. This question has already come in the IIT exam, but it is very easy. Just look at the pattern. No, ये last है. We have three terms, that is log. Log के अंदर की term, whatever there is in the bracket of log, that will be always dimensionless. Now what is the meaning of dimensionless? As it is clear from the name, no dimensions means M0, L0, T0, or you can directly write 1. Anything raised to 0 is 1. Clear? log के अंदर की टर्म हमेशा डायमेंशनलेस होगी. एक्सपोनेंशियल की पावर e की पावर हमेशा डायमेंशनलेस होगी. एक्सपोनेंशियल को एंटी लॉग भी बोलते हैं. एक्सपोनेंशियल is also called antilog. Clear? And antilog and log are reciprocal to each other. जैसे 1/5 और 5 एक दूसरे का रेसिप्रोकल है, ऐसे ही log और antilog एक दूसरे का रेसिप्रोकल है. Clear? And they can be cancelled out. I will tell you with the example over here. And third is any t ratio. I'm taking the example of sine. The angle inside is always dimensionless. यहाँ पे sin की जगह पे cos भी हो सकता है, tan भी हो सकता है, secant भी हो सकता है, cosecant भी हो सकता है, cot भी हो सकता है. सब केसेस में एक जैसे ही सोल्व करना है. So any t ratio over here. I'm taking one by one all of them. Suppose अपने पास एक क्वेश्चन है. F is equal to a log of बी एक्स स्क्वायर प्लस सी। मैंने आपको पहले ही बोला लॉग के अंदर की टर्म डायमेंशनलेस है। सो फर्स्ट ऑफ ऑल टू सोल्व दिस वन आई विल पुट अप द डायमेंशंस। फोर्स इज एम एल टी माइनस 2 a log of bl2 plus c, because the term inside the log is dimensionless. So I will write bl2 plus c is m0 l0 t0. Now because this formula is by default correct, each of the term must have same dimensions, so I can write directly c as m0 l0 t0. Then I can write bl2 is m0 l0 t0. So b अपने पास क्या आ गया, m0 l minus 2 t0. So I've got the dimensions of b as well as c. But as I've given you, the term inside the log is always dimensionless. Dimensionless means 1. So this whole term will become 1, and a into 1 is a. A will be equal to f, so I can directly write f is equal to a, or a is equal to mlt minus 2. Is that okay? Any doubt up to any point? Clear? In this way we can solve the term containing the log. Then comes exponential. ये ना तीनों ही आपको log, exponential and t ratio एक जैसे लगेंगे. Then is exponential. Suppose e raised to power force is e raised to power a, and over here is suppose a bx square plus c. I told you that the term in the power of exponential is dimensionless. So सबसे पहले सबके dimensions put up करते हैं. Force is mlt minus 2 a e raised to power bl2 plus c. bl2 plus c is dimensionless, m0 l0 t0. I can directly compare them. So c will be equal to m0 l0 t0. c की डायमेंशन डायरेक्टली आ गई अपने पास. Then is bl2 is equal to m0 l0 t0. b is m0 l minus 2 t0. We have got the dimensions of b and c. And as I've told you that the exponential is a constant. Its dimensions are 0 or 1. That is dimensionless. So I can directly write f is equal to a into 1. f is mlt minus 2, so that will be equal to a. So we have got the dimensions of a also. Similarly, I can write any t ratio. Say sine, third one. This was the second one. F is equal to a sine of bx square plus c. I told you the angle is dimensionless. The term inside the t ratio is always dimensionless. So if I put up the dimensions, mlt minus 2 for force, a sine of bl2 plus c. So by principle of homogeneity, bl2 plus c must be equal to m0 l0 t0, or I can directly write that the c is equal to m0 l0 t0, and bl2 is also equal to this. So c is m0 l0 t0, b is m0 l minus 2 t0. So we have got the dimensions of b and c, and as this whole term is dimensionless, so it will be 1 only. So f is equal to a, or a is equal to mlt minus 2. Now with this numerical, all the types of numericals based upon principle of homogeneity are covered. I will take up one or two typical one also. Say if I write f is equal to integration of dx of vx square minus c, and we have a outside. Integration formulas. Dx is the change in length. Clear? Then I can write force is mlt minus 2 a, dx is change in length, which means length again, upon bl2 minus c. Now, as I've told you, according to principle of homogeneity, if we expect the two terms, they must contain the same dimensions. That means BL2 will be equal to, say I take the example over here, say X instead of C. BL2 must be equal to L. So I can write BL2 is equal to L. We are having A over here and B over here. So I can write B is equal to M0 L minus 1 T0. So we've got the dimensions of B. Again, from the same equation, I can write MLT minus 2 is AL upon, because this is length, this should be length, length minus length is length only. So this L and L will get cancelled out. A will be directly equal to MLT minus 2. So in this way we can solve the integration also. Clear? Then we can have the formula for the differentiation also. All these comes, you won't get these numericals in your normal textbooks. Energy is equal to, say, A d by dx of bx square plus ct plus xt. Now, the first thing is we have to put up the dimension for each of the quantity. Energy is ml2 t minus 2 is equal to A d by dx. This dx is a change in length. This d is a constant. So I will write L only over here because of this dx. And inside the bracket we are having BL2 plus CT plus LT. Because we are adding these three terms, they must be equal. This is LT. This must be LT. So if I say that, and this must also be LT. So if I compare these two terms, first CT is equal to LT. So I get CS, T will get cancelled out. You are left with M0 L1 T0. Now second term, if I compare this BL2 with LT, so I will get B is equal to L minus 1 T and M will be 0. Now we have got the dimensions of B and C. Now because this is LT, this must be LT, this must be LT. LT plus LT plus LT must be LT. So again I'm going to rewrite this one. M L2 T minus 2 is A by L outside, and inside the bracket it will be LT. This L will get cancelled out and this T will come over here and make the dimensions for A as ML2 T minus 3. So in this way we can solve the dimensions for A, B and C. Thank you students. In the next video we will take up the second use of dimensional analysis, that is derivation. Stay home, stay blessed and take care of yourself. Thank you.